Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study the definitions and terminologies related to centroid, center of gravity, and center of mass. Here, what is center of gravity? Center of gravity is nothing but a point through which the orientation of the weight of the body acts at that point. Okay, it is for all, in spite of all position of the body, whatever the shape may be. It is arbitrary shape, the complete arbitrary shape of the weight of the body passing through at certain point. That point is known as center of gravity. It is generally represented by CG or G. Centroid, the point, what is the centroid? The centroid is the point of a total area at which the total area of the plane figure such as a rectangle, square, circle, etc., trapezium is assumed to be concentrated. It is known as centroid of that area. Centroid of that area. Now here, the centroid is also represented by CG or simply led by letter G. So that centroid and center of gravity are at the same point. That's why generally if you calculate the center of gravity or centroid, the methodology to calculation of the CG remains the same. Now the center of gravity, here there is the key term, there is the whole weight of the body acts. And where is centroid, the key term is the plane areas, plane figures. Here the whole weight of the body, here the plane figures acts. Now the third term is known as center of mass. The center of mass is what is the center of the mass? Is the point at which the whole mass of the body is concentrated, is known as center of mass. Now the center of mass, centroid and center of gravity all are denoted by CG or capital letter G. Now what is centroid also called? Okay, suppose if we consider the triangle, the three medians of a triangle meet at one point. That point is known as G or center of gravity. It is passing through medians, three medians here. It is passing through that. There are three medians. This is point G. This is a triangle. So what is the centroid of the triangle? How to calculate the centroid, where it will be? So here the three medians intersects at one point. That point is known as centroid or center of gravity. So that's why the centroid is also known as center of gravity. So now the next term here is this. What is the centroid formula of a triangle? If you consider the centroid formula of a triangle, if we consider it, there are different three coordinates x1, x2, x3 and y1, y2, y3. Okay, y1, y2, y2. Okay, if we consider it, there are x1, y1, x2, y2 and x3, y3. Now the geometric center of the object, is known as the centroid. The centroid of a triangle can be determined as the point of intersection of all the three medians of a triangle. And the centroid of a triangle divides all the medians as a ratio of 2:1 ratio. 2:1 ratio, it will divide or divides all the medians. Now the term, what is the centroid formula, as we are mentioning here? As I mentioned here, the three medians intersecting at one point is known as the centroid. The centroid formula of a triangle, this is the centroid formula of the triangle is, that is x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3 is the mathematically we already studied in +2 classes or intermediate or 10th class. Now where C is the centroid, the triangle, x1, x2, x3 are the x coordinates of the three vertices, and whereas y1, y2, y3 are the y coordinates of the three vertices. Now coming to various sessions here, the rectangular area, triangular area, trapezoidal area. Coming to here, the portion, what is the centroid of this rectangular area? Now what is the area for this rectangle? Length into breadth, that is A into B, that is the area. And what is the coordinate? This is the centroid of this rectangular area. So what is the centroid for this? Centroid CZ, or here CZ or G. Now G for this bar, X bar and Y bar. The X bar and Y bar for this local coordinate for the centroid of this rectangular area, that is B by 2, and Y bar Y is A by 2. Okay, now coming to triangular area. For the triangular area portion, what is the area of this? Of length into of height, of base into height. That is area for this portion of this triangular area is that area of this of, what is the base here? B plus A or A plus B. What is the height? H. Now consider here the reference axis for this is, here it is the H total. If we consider the reference axis, we have to consider what is the reference axis for calculating the centroid. The reference axis means the vertical axis YY is the extreme left side, and XX axis is the topmost of the bottom of the geometry. Now after getting this, what is the bar X? The bar X is here, this bar X and bar Y. The bar X, if we consider extreme left, that is the B. And what about, it is the B, and bar Y, it is, what is the bar Y here? The bar X is not the B. How to calculate the bar X is here? The reference axis, vertical reference axis. The reference axis comes B plus A minus B plus 2A by 3. This is the bar X. What about bar Y? The bar Y is the H by 3. The vertical distance, the bar Y. And if you consider the trapezoidal area of this trapezoid is of times length base, that is L into A plus B. And here, what is the bar X and bar Y? The X bar X for this trapezoidal area is, bar X is L by 3 times A plus 2B by A plus B. Bar Y equal to half of A square plus B square plus AB by A plus B. This is bar X and bar Y. Here the point is that very important, for this individual section rectangular area, the centroid is if it is a breadth by 2 and a length by 2, that is a centroid, or CG or G. Now whereas here the centroid of triangular area, if it is a right angle triangle or any triangle, consider it here. Now what is this? This height is H. Height is the H, and this is the G point, the centroid point. And what about bar Y and what bar X? And this length is, if you consider, it is the base. If you consider the total base is the B. Let us go to next slide. You can understand better. Suppose the triangle height H and this is B. This is the centroid point. Now what is this distance is? Bar Y. And here this distance is bar X. Now this bar X comma bar Y. Bar X equal to horizontal distance, that is B by 3. Bar Y is H by 3. Why here? The reference axis we considered here, it is the reference axis. This is the horizontal reference axis. This is the vertical reference axis. Okay. Now consider here circular area. What is the centroid of circular area? The centroid of circle, it is at a distance of R from reference axis. From the reference axis R, area is pi r square. That is circular area. What about centroid of semicircular area? That is bar Y is 4r by 3 pi. Bar Y equal to 4r by 3 pi. What about bar X? Consider the reference axis. This is the reference axis. Here it is the reference axis if we consider, and here the bar x equal to r, bar y equal to r. Reference axis, consider it. Now here bar x equal to r. Now consider here whatever quarter circular area, centroid, coordinate of the quarter circular area, that is here the reference axis, consider this portion in this manner. So for that consideration, for this reference axis here to here, then what is bar x equal to 4r by 3 pi, bar y, that is 4r by 3 pi. Now the next category is the next figure is that circular sector. The circular sector, the reference axis here it is for this figure. Now bar x equal to 2r sin theta by 3 theta. Bar y, whatever bar y, it is passing through the centroidal axis. There is no bar y, that is 0. Now there is the circular sector. Now the point is that reference axis. Now the reference axis are very, very important to calculate the centroid of a particular plane or particular figure. Now coming to elliptical areas and general spanner. For elliptical area, the centroid is located. And what is the reference axis here? If you consider the reference axis A and B, bar x and bar y. Now here, this is the reference axis for this, whatever here, this position. Now bar x for this semi-elliptical area is A, bar y is 4b by 3 pi. Now for this same quarters elliptical area, the quarter elliptical area, the bar x equal to 4a by 3 pi, bar y equal to 4b by 3 pi. For this general spanner, you can see area is that AH by n plus 1. Now here the point is that these are the simple plane figures are required to find out the centroid of composite sections. Now we are going to discuss about symmetry, symmetrical axis, whether the geometry is symmetrical about axis x or axis y. Okay, here in this figure, symmetrical about axis of symmetry, if we consider about which axis the figure is symmetrical. What is the axis of symmetry? First of all, you have to learn. If we consider any geometry like such as rectangle. In this rectangle, if you fold this rectangle about horizontal, fold horizontally, both the top and the bottom geometry is the same. The top and bottom geometry is the same. The top and bottom geometry, it is the same. That means it is symmetrical about axis x. And if you fold vertically, is like a here. If you fold vertically, then the left and right side, and right side, the geometry is the same. That means it is symmetrical about axis y. So this rectangle is symmetrical about two axes. One is horizontal x, another is vertical y. That means it is a two lines of symmetry. Two lines of symmetry. Alright. So if particularly if you consider another shape of the figure, we are going to make it now. There is a T section. If there is a T section, we draw a line. If you fold vertically about vertical axis, it is symmetrical on the left side and right side. Geometry is the same. This portion, exactly this portion is the same. Okay, that means it is symmetrical about axis y. It is symmetrical about axis y. Okay, left side and right side both are same, axis Y. Now, if you fold horizontal axis, if you fold this T section, horizontal axis, the top and the bottom geometry is not same. That means it is not symmetrical about axis XX, horizontal axis, but it is symmetrical about vertical axis. That means it is a geometry of single line of symmetry. Single line, one line symmetry of T section is the one line symmetrical section. So now you understood the concept of the symmetry. What is symmetry? Now here, let us begin. Here the section is the L section. You fold this L section about vertical axis and about horizontal axis. If you fold it horizontally or vertically, here if we consider it the horizontal axis, the top and the bottom geometry is not same. So it is not symmetrical about horizontal axis. Now if you vertically, if you draw horizontal top and bottom, if you fold vertically, left side portion, right side portion is not same. Geometry is not same. The geometry here, the left side portion, this is the portion, and the right side portion, this is the portion. It is not same. That means this L section is unsymmetrical section. Unsymmetrical section. For unsymmetrical section, we need to find out, if we want to calculate the centroid, we have to calculate bar X and bar Y both to locate the centroid of these unsymmetrical sections. Okay. The next, coming to here, this figure, another figure. Now, can you tell me what is this? Is this symmetrical about which axis? Symmetrical about which axis? If you fold horizontally somewhere else, it is not symmetry, top and bottom. No, not. It is not remain same geometry, so it is not symmetrical about horizontal axis. And if you fold vertically somewhere else, it is also not symmetrical about top and bottom. Geometry is not same. So what happens? It is also another what type of section? It is a unsymmetrical section. It is unsymmetrical section. Okay, not all for okay. So for unsymmetrical section, what to be calculated in order to find out the centroid? The centroid for this unsymmetrical section is what? Bar X and bar Y both are to be calculated. The centroid is represented by horizontal distance from vertical axis, from reference axis is the bar X. The vertical distance from horizontal reference axis bar Y. G equal to bar X comma bar Y. This is the coordinate. That is the location of the centroid. Okay. Next, I am going to show you some of the symmetrical sections about at least one line of symmetry. That's why it is called symmetrical sections. Unsymmetrical section means the both about axis, the both lines axis. It is not two lines of symmetry. Not at all symmetrical about both horizontal and vertical axis. Such sections are known as unsymmetrical sections. If we consider the rectangle is the double line of symmetry. It is symmetrical about horizontal axis and vertical axis. And another figure, this axis of symmetry about here, the I section. If you consider the I section, it is symmetrical about horizontal axis and also vertical axis. That's why it is a double. I section is the double line of symmetry. The next, C section. If you consider C section is nothing but a channel section. For this section here, the geometry of this it is horizontal. It is symmetrical about horizontal axis, but not symmetrical about vertical axis. So it is that's why it is a single line of symmetrical section. Channel section is the single line of symmetry. So it is at least a single line of symmetry. That's why it is, these sections are known as the symmetrical sections. Okay, one is completely symmetrical or partially symmetrical, not like that. This is symmetrical or unsymmetrical. Unsymmetrical means it is unsymmetrical about both the axis, horizontal and both vertical axis. It is unsymmetry. Such sections are known as unsymmetrical sections. What you have studied here, these are unsymmetrical sections. Okay, this is also unsymmetrical section, L section. The next we are going to here find out is yes, these are the certain figures. The centroid of a simple areas. The centroid of simple areas, the triangle, the shape of the triangle as we have studied, b by 3 and h by 3. Area is of base into height. The semicircle we have also studied. Now here the point is that in the semicircular area, the reference axes are, this is another reference axis, this is the centroid, center distance. Now the semicircle is symmetrical about axis y, and that's why it is symmetrical section. So what is the bar x? The reference axis passing through the centroid of the semicircular area. So the bar x, the reference axis passing through centroid, the bar x equal to 0. What about bar y? Bar y equal to 4 r by 3 pi. Okay, what is the area? Pi r square by 2. It depends upon the reference axis where we are locating, then we can find out like that. Now the quarter circle is already studied here, that is bar x and bar y. The reference axis x is here and y, that is 4r by 3 pi, 4r by 3 pi. Now the rectangle, the quarter circle is over rectangle. H and b is the length, h is the height. What is bar x? That is b by 2, bar y h by 2. These are the concepts, and area is bh. Why we need the centroid is dependent upon 3 parameters. Okay, one is reference, one is area, another one is distance of the centroid of individual section from horizontal distance from vertical axis and vertical distance from horizontal axis. Now here the bar x and bar y area we calculated. What is the formula? What is the expression for solid sections? Here suppose there are T section here. T section, it is section 1 and section 2. This is the reference axis. If we consider the reference axis here, it is the reference axis is, this is x and y, or it is symmetrical about which axis? Symmetrical about axis y, vertical symmetry. So the axis geometry passes here, the reference axis are. For this T section, bar x equal to 0. What about bar y? The bar y expression is here. It is a1 y1 plus a2 y2 by a1 plus a2. What is the a1 is? Area of the rectangle of the section 1. Here it is again. And a2, area of the rectangle of the portion 2. a1, a2. And what is y1? y1 is individual centroid, is the g1. This is the y1, distance of the g1 to xx, that is bar y1. y2, it is g2, distance from g2 to horizontal axis xx. g2 to xx is known as y2, y1, g1 to xx is y1. Now substitute here a1 and a2 are area of sections. a1 y1 plus a2 y2 by a1 plus a2. This is bar y. Bar x, if you want to, the expression for bar x equal to a1 x1 plus a2 x2 by a1 plus a2. The a1 and a2 are areas of sections. If it is rectangle, that is a rectangular area. If it is triangle, it is a triangular area. Whatever geometry, that is geometry area. This is a1 and a2, sir. Those geometry areas. This x1 and x2 are, this x1 is horizontal distance of g1 to reference axis, and x2 is g2 to horizontal reference axis. Here the reference axis is YY for this T section. So what is the G12? This YY 0, x1 equal to 0. And what about x2? X2 also passing through G2. G22 this YY, that is x2 equal to 0. Substitute here x1, x2 zeros, then bar x becomes 0. So bar x equal to 0 and bar y equal to a1 y1 plus a2 y2 by a1 plus a2. Thus we have to substitute in this the areas and distance of x1, x2 and y1, y2. Then we can get it. We can locate the centroid of the section. Now here another thing is that axis of symmetry we have studied. We can go for if you want to calculate how to calculate the centroid, definition terminology is not a problem, but we can understand how to calculate the centroid of this section. Here this complete geometry is divided into 3 parts: section 1, section 2 and section 3. These are all solid. That's why here the bar x is symmetrical. It is unsymmetrical section. That's why we have to calculate bar x and bar y. The bar x equal to a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3. And bar y equal to a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. Now why I consider here, these are the additions. a1 x1 is added to a2 x2 and added to a3 x3 by a1 plus a2 plus a3. Why? The point is that these are all are solid sections. If it is a hollow section is there, suppose there is another section, there is a circle is there. This circle is having a hollow portion. Now this is the complete solid sections. What is the centroid of this section? Consider this is hollow section is the fourth one. Then for that case, what is bar x and bar y comes for hollow section case? We have to subtract that hollow section area, that is minus a4 x4 minus a4, the denominator. Now for this bar y, what happens? Minus of a4 y4 in bottom portion, that is a4. This is bar x and bar y. 1, 2, 3, section 1, section 2, section 3 are solid and section 4 is the hollow. For after removing that hollow section, what is the geometry? What is the centroid of that section? Here you can see how it looks. Okay, like that. For this type of section, how to find out? So section 1, section 2, section 3 and here it is 4. So 1, 2 considered as a solid. From that we subtracted this fourth portion, that is hollow portion. Okay. Thus we can calculate the hollow sections also. Okay. Now this is the axis of symmetries. What is it? Why should we study this type of symmetries? Why not a different? Because these sections are of the beams. Generally, maximum sections of the beams are I section, C section, or rectangular sections. These are the standard sections. Mostly are used for construction purposes or for the case of mechanical industries. The beams, like iron bars or sections, is having I section, C section, and rectangular sections. It's not solid, hollow rectangular sections, etc. Okay. So what is the importance of this here? What is the importance of this centroid? The next definition is that so far we covered what is the centroid of the rectangle, centroid of the circle, centroid of the elliptical area. Okay. Now there are simple plane geometries and also composite sections. Suppose if we consider a T section or I section. Suppose if we consider the I section, for this I section, what is the centroid formula for this I section? Okay, you can, by looking at the dimensions are given here, it is 100 millimeters and here it is 100 and here it is 10 and this is also 10 millimeters and this portion is some 100 millimeters. What is the centroid of this I section? If you want to calculate by using expression, derived expression, the section 1, that the top flange, section 2 is the web, section 3 is the bottom flange. For this type of section, bar x equal to a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3, and bar y equal to a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. This is the calculation. If we calculate, we'll get at this point what is the bar x comes as 50 millimeters, bar y is it will come as 50 plus 10, 60 millimeters will come. How it comes? How to calculate here? How I got it this one? Because it is symmetrical about both axis x and axis y, provided this bar x and bar y, the reference axes are here. They are the reference axes. But there is another answer also there. If the reference axes are, this answer is meant for the reference axes are at the extreme edges, left side extreme and bottom. Suppose if the reference axes are for this I section in the middle, if it is symmetrical about both axes xx and yy, it is symmetrical, two lines of symmetrical section. For the reference axis, here it is. Now what about centroid for this reference? Bar x and bar y, 0, 0. Bar x and bar y are 0, zeros. As I mentioned here, as given here already, here it is 100 millimeters and 10 millimeters and 100 millimeters, and here it is 10 and here it is 100. Even though they were given dimensions also, the bar x, okay, and the bar y is passing through the centroid of this portion, then here it is, answer is 0, 0. Alright, now if the reference axes are, extreme corners, no need to calculate bar x equal a1 x1 plus a2 x2. It is symmetrical about axis x, horizontal and vertical axis. So what is the horizontal distance? 100 by 2. That is bar x equal to 50 millimeters. What about bar y? The bar y is from this total length by 2. It is 100 plus 10 plus 10, 120. 120 by 2, that is 60 millimeters. Okay. This is the location. If the reference axes are xx and yy is extreme corners, then bar x and bar y 50, 60. If the reference axes are this horizontal and vertical passing to the centroid, then centroid is located 0, 0. So these are the concepts. If you understand where is the reference axis, first you have to locate while calculating. Okay. Now coming to the point of very important, one of the questions generally, is the centroid lies on the geometry or not? Is the centroid lies on the geometry? Centroid lies on the geometry of the figure. Geometry of the figure. Yes, we can say that centroid lies on the geometry of the what type of figures? It is lies on the geometry of the figure. When on the geometry, CG lies on the geometry. When for the sections of symmetrical, both two lines of symmetrical sections, symmetrical of XX and YY. For two lines of symmetries, the CG lies on the geometry. Next, another answer is that centroid doesn't lie on the geometry. It doesn't lie not on the geometry. For what figures? It is not on the geometry of what? Maybe or may not be also for unsymmetrical sections. On may be or may not be on the geometry of what? Unsymmetrical sections. Unsymmetrical sections. Okay. Centroid lies on the line of symmetry for symmetrical sections. At least one symmetrical line should be there. If it is axis about, it is symmetrical about axis XX. Okay, it is lies. Centroid lies on this axis XX. If the centroid, if it is symmetrical about axis YY, vertical axis, the centroid lies on this axis. Location of the centroid will be on this axis of symmetrical line. Okay, these are the particular some concepts through explained by taking as the definitions and terminologies. So with this, you can understand the various sections of geometry on the concepts of the centroid. Okay, these are references followed in this session, this lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.